Good day, learners. Godfrey's here, and I'm proceeding with the aspects that we're looking at that is related to map work. So under that line, I want us to proceed with what you're supposed to look at. And today I want us to start from a very simple aspect, which is basically talking about the grid reference. Okay. Now, when we understand, what do we understand by grid reference? Grid reference is basically looking at the location of geographical features. The location of geographical features. So when you talk about the location of geographical features, we're basically using two aspects. And what are they? We're using, number one, we're using the line of latitude, okay, and the line of longitude. There are basically two aspects that are very important here, the line of latitude and the line of longitude. The line of latitude and the line of longitude are the very important aspects that we should consider. But you must note, learners, that when you're finding grid reference, normally on a map, we start with the line of latitude. Latitude comes first before you go to the longitude. So what you must note with the latitudes, that latitudes increase northwards or southwards, depending on which position you are located in, and the longitudes are increasing either eastwards or westwards. That's why you see every end of the latitude you write S. That is if you're in the south. If you're in the north, you write N. Every end of longitude, you write E if you're in the east. And we also write W if you are in the west. Okay, so what do we know here? When you looking at the exact position of geographical features, we use minutes, degrees, minutes, and seconds. So what you must note, learners, is that 1 degree has got 1 degree has got 60 minutes, and 1 minute has got 60 seconds. Meaning to say, from here to here, this symbol here is reflecting a minute. This symbol here is also reflecting a minute. Meaning from here to here, there is strictly 1 minute, which means this 1 minute has got 60 seconds. How do we show seconds? We show seconds with the two symbols. Can you see here? Here, there are two here. You can see the symbols here are two symbols. So what do we do if you want to locate the degrees, minutes, and seconds? What do we do if you want to locate the degrees, minutes, and seconds? You must first of all start with the degree. But as I'm telling you, learners, that we must start with the latitude first. So the mid-degree for a latitude will always be indicated, and therefore you'll be in position to see it on the map on top there. Let me say the degree is 23. Just using an example here, that if our degree is 23, okay, so how many minutes are there? You start. If this is the 35 minutes, then if the feature is around here, of course you cannot take this 32. Sorry, if the feature is around here, you cannot take this one. You take 0. 0 minutes. So if it's 0 minutes, then how many seconds? There, that is when you estimate. From here to here, when you divide into half, it gives you 30. So that means 30 above, 30 down. So 30 here, 30 here. So what do? We divide even the 30 into 2 so that you can get the 15, the 15. Or you can divide this into tens, like you see here. 10, 20, 30, 40, 50, that means to here, it's going to be 60. And therefore, if the feature is here, then you take the 20. So it's going to be 33 degrees, 30 minutes, 23, sorry. It's going to be 23 degrees, 0 minutes, and then 20 seconds south. Then we go to the longitude. Okay, so the longitude, normally you find out that the longitude will have also a degree somewhere here. Practically, I would like to put the map here so that you can see how we find out. So in case you have a degree here, let me say 30 degrees, and it's starting with 31 minutes to go to 32. That means the degree, if my feature is around here, where I said the 20 is, so that means we shall take the 30 and we write the minute, which is 31 minutes. So it will be 30 degrees, 31 minutes, Then you start looking for seconds. What do? You divide this into sections. Just like you see these ones divided in 10, 20, 30, 40, 50 to 60. So that means how many lines you have here? 1, 2, 3, 4, 5, 6. The same way we shall divide here. 1, 2, 3, 4, 5, 6. I want you to look at this. This is what it means. So we have the 6 here, we have the 6 here, which means 1, 2, 3, 4, 5, 6, meaning that each is 10, 10. So if the feature is here, you locate the minute, you locate the degree, and you locate the degree, you locate the seconds, and you locate the minutes. Therefore, this is what you are going to see. Look at this. If this is feature A, how many degrees are they going to be? How many minutes are they going to be? In this case, we don't have degrees, we have just minutes. That's why you see here, it is saying 0 minutes for A. So how many seconds? It is saying 20 because it is sitting on the line of 20. That is for the south. Meaning that if you want to go for the east, you look up here. You see these are lines, they are drawn like this, meaning that these ones are increasing to this side. And this side is the east, therefore it is the easting. So this means we take a 30 as our minute. So the degrees, the seconds are going to be, there's a 20, there's a 10, there's a 20, there's a 30. So if you look at this A's here, so it's going to be 10, 30, 20, 40, 50, 60. No, it's going to be, okay, 10, 20, 30, 40, 50, 60. And when you look at this, it's 10, 20, 30, 40. That's why you see here is a 40, and we put E. The reason why you put E, because it is easting, okay? Or it is a longitude. Then when you look at B, we try to find out B. It's still the same minute, which is 0. The assumption here that we would not know how many degrees are here, but let us deal with what we have. We just need to find out the seconds and the minutes. So the minute that we have for the latitude, I told you we start with the latitude, which is 0 here. So the latitude is a 0. So you write the 0. So B is sitting at which line? You count 10, 20, 30, 40. That's why here is a 40 minutes. This symbol, if they are two like this, is minutes. Seconds. If it's one like this, it's minute. So here we shall have another one, which is for the degree that we do not have at this particular moment. Now, you go to the longitudes. The longitudes are the ones that are sitting vertically like this, but they are increasing to the east. So what minute do we have? It's a 31. That's why you see the 31 is written. So B is sitting at which line? If this is 10, this is 20. We write 20 seconds east. So learners, listen. If you miss out writing south and east, S and E, obviously you will not get your answer right because you would have missed something there. All right. Now, those are some of the aspects. I just wanted to include that because it is very important. Last time I left it out. So if probably I look at it and I start from there, then it will give you a starting point. So whatever we have missed, we shall get lessons. Now, learners, I want you to know that map work is applied on different topics. Each topic we look at in geography will have its application on map work. So today, I want to look at the application of at least geomorphology and its map work. Maybe when you come again or when we meet again, I'll have to look at the application of climatology on map work. And learners, you must note that for you to understand clearly map work and pass it very well in your final examination that is coming very soon, you must be having at least some theory with you. The theory is going to assist you to be applying concepts nicely, because it's going to be very difficult for you to apply concepts if you're missing the theory part of it. Therefore, it is very important. It's very, very paramount. It's very, very important that you have enough theory such that you can be in position to apply it on a map. So we know what geomorphology means We have looked at geomorphology in our classes with our respective teachers. You have talked about rivers, the river system. You have talked about river capture, river rejuvenation. You have talked about the drainage systems. You have talked about the different concepts in drainage, katabatic and batic winds, all those concepts. So we need now to come to the map and apply it. But I'm going to try and apply a few aspects in that we see how can we do it on the map. The starting point that you normally do on the map is coming in line with the drainage patterns and their characteristics. We know that when it comes to drainage pattern, what do we understand? Drainage pattern just talks about the layout of drainage systems on this earth, on the Earth's surface. How do they appear? Which shape do they form on the Earth's surface? This is when we talk about the aspects of both radial drainage pattern, rectangular drainage pattern. You talk about the spiral drainage pattern, among others. So in those drainage patterns, what are their characteristics? The dendritic, the trellis, what are their characteristics? How do we apply them on the map? So that is my main area for today. Okay. Now from there, I want us to look at that map extract. What do you see? When you look at that extract, you will understand that this here, can you look at these learners? When you look at this, what do we see? We see that we know that these brown lines are representing the nature of relief. So they are showing height above sea level. Those are contour lines. These blue lines here, you see, they are showing the drainage system or the rivers. Which shape do they form? I want you to be in a position to identify. So when you look at this, you will know that this one is a dendritic drainage pattern. What is a dendritic drainage pattern? That is a drainage pattern that looks like a tree branch or a tree-like feature, Look at this. This is the main branch of the tree. Then it has got other branches just that are getting off the main branch of the tree. So that's why you see it looks like a tree feature. You go back to your theory and you remember that those kind of drainage pattern or the dendritic drainage pattern, why does it appear like that? What is the nature of the underlying rocks? You remember, you must have talked about this in your classes with your teachers, that they have uniformly resistant rocks. Underneath, the underlying rocks are uniformly resistant rocks to erosion, meaning that uniformly resistant rocks will determine the nature of the dendritic drainage pattern to be like this. They have the same rate of resistance. Okay, so this is going to be dendritic. So if they tell you to locate maybe block C1 or block A1 or block B5, and they tell you to identify the drainage pattern, first look at the layout. Which feature does it form? If it forms such a kind of feature, obviously it's a dendritic drainage pattern. Now, we come here. When you look at this drainage pattern here, you'll find out that these ones are very short tributaries. This is the nature of the land. This is the nature of the land. This here, we have very short tributaries that are joining at right angles. So when you look at those very short tributaries, what do we understand? These short tributaries tells us that this is likely to be a trellis drainage pattern. Why is it forming this kind of drainage pattern? What is the nature of the underlying rocks? That is very, very, very important. The nature of the underlying rocks should be that these rocks have this trellis. They will have very short tributaries because the rocks have got maybe joints. Okay. Now, if this is trellis, what will this one be? This is a crack. Okay. That means which drainage pattern forms when there are cracks? The cracks act as a path. It acts as a way to show us where the rivers will find its way through. You understand? So that is going to be the rectangular drainage pattern. So when you look at it, it uses the cracks to find its way out. So because of these cracks that are forming, meaning that the rocks will have either cracks or we say joints, okay, or lines of weaknesses. So in the process when a river is flowing through, it uses the advantage of the lines of weakness to form a certain layout on the earthly surface, which is now going to be rectangular. So the tributaries are going to be forming also at right angles. Just like here, the tributaries are joining at right angles. The only difference here that the tributaries are very short tributaries. Now we'll look at this one here. When you look at this one here, you'll find out that which drainage pattern does it form. When you look at this here, this is a mountain. These are the tributaries that are pouring outwards. You can look at the angle at which the tributaries are joining the main streams, and you can easily tell the direction to which they are flowing to, meaning that this is going to be a radial drainage pattern. Why? Because the tributaries are pouring their water outwards from a higher central place. Look at the tributaries. Here the tributaries are forming a V outwards. Look at this one, they are forming a V outwards. Look at this one, they are forming a V outwards. So this river is going into different direction, and therefore this forms what we call the radial drainage pattern. So guys, you can be in position to identify this on the map. These are free marks, learners. If you try to understand this, what determines the shape of this kind of drainage pattern is going to be basically the mountain nature or the dome-shaped nature of the relief. So the mountain determines the rivers to be flowing outwards. Okay, now that is the application of geomorphology. Remember, I told you that, for example, paper 1 is only going to have mapwork assessments on those two topics, which is geomorphology and climatology. If you look at those two mapwork assessments that we are going to have on geomorphology and climatology, please, learners, be in position to know how do we apply the drainage pattern. How do we know that if this is a permanent river, this is a seasonal river? How do we tell the direction of the river? How do we tell the underlying rocks? But this must be in line with the knowledge that you have in your theory that you have covered. All right. Now, still is something that we need to apply on the map. What is this topic here? This topic in mapwork and in theory is going to be known as the drainage density. What is drainage density? Drainage density is the number of streams that are existing in a drainage area, or number of streams per drainage area. Now, when you look at this, we are having different categories. If you check here, somewhere from here up here, we have got a number of streams which are too many. So meaning that on the surface, on the earth's surface, somewhere here we have a lot of drainage or a lot of streams that are existing on top of the earth's surface. These streams form what we call high drainage density. What is high drainage density? This is where we have a lot of streams that are flowing on the earth's surface. So up here, if you see an area having a lot of streams like this, it simply means that is what we call high drainage density. Somewhere up down here, we have what we call low drainage density, because when you compare the number of streams that are existing here and not the same number of streams that are existing here, meaning that here is a low drainage density because there are fewer streams. But you must go back to your theory and remember that what did we say? What are the factors that are determining the number of streams in an area? If it is a high drainage density, what are the factors? For example, high rainfall amounts. Remember, learners, we say that if the area is experiencing a high rainfall amount or a lot of rain, it simply means that there will be a lot of rivers that are flowing on top of the earth's surface. That will mean that a lot of rainfall will mean high drainage density. And then we also looked at the fact that what will determine the high drainage density is the nature of the rocks, that we say they must be hard rocks, meaning that hard rocks will reduce the rate at which water is penetrating through the earth's surface, meaning that it reduces the rate of infiltration and increases the rate of surface runoff. And surface runoff will increase the amount of streams that are existing on the earth's surface. Hope we are clear, learners. We also look at the slope, which is supposed to be steep. Now, these factors here are only considerate or are only focusing on high drainage density. These factors down here are only focusing on low drainage density. So under that line, we are saying that if here we have got a steep gradient, what does that mean? If the gradient is very steep like this and it rains, that means most of the water will be in position to run off the surface, And if it is in position to run off the surface, it will result into increase the number of streams, and it will increase surface runoff, reducing the rate of infiltration. So with the reduced rate of infiltration, it will lead to increased surface runoff, and that will determine high drainage density. Okay. Then we also look at the vegetation. We say that what should be the nature of the vegetation if it is a high drainage density? What do you need to understand here? That if it is a high drainage density, that simply means if it's a high drainage density, we are only going to be in position to have less vegetation. What is the implication here? That if an area is an opening with limited vegetation, whatever is going to happen on the Earth's surface will not be in position to run off. I mean, it will not be in position to penetrate down or to infiltrate down. Why? Because the vegetation is limited. So when it rains, there will be a lot of surface runoff, and there will be limited or there will be reduced infiltration on the Earth's surface. Meaning that there will be increased, meaning that in this case, if we have got limited vegetation, when it rains, most of this water will be running on top of the surface. So remember, trees, using their roots, they can be in position to hold the soil tight. And because of the falling of the leaves from the trees, it will help to keep the soil compact. So if the soil is compact and the roots are also existing, it will help in that when it rains, that water, the surface runoff will be reduced as the trees will hold the soil. Number two, that if the trees are a lot or the vegetation is a lot, the water will be in position to infiltrate down the soil. That means we shall have less surface runoff. Okay, I mean, we shall have water that is running, we shall have more infiltration than surface runoff. I hope it is very clear. I don't know. And then we have what we call less infiltration, but this is like what I'm explaining. If there is less infiltration, there will be more surface runoff, and more surface runoff will determine high drainage density. So in most cases, learners, you're going to be asked these questions. If a question comes and say, refer to block C1, and when you look at C1, you will see that there are a lot of streams. And the first question will be, let me just say, the first question might be that determine the nature or determine the drainage density. So we are using two. It's either high drainage density or low drainage density. It depends on which area you're identifying. If the streams are too many compared to maybe, here in most cases, they give two areas for comparison. Say, refer to block C1 and block B5 on the topographic map. And they say, which block has got a high drainage density, which block has got a low drainage density. So you look at the number of streams there in comparison to another one, and you see that if this area has got many, let me say B5 has got a lot of streams, then you will say it's a high drainage density. If C1 has got fewer streams, then you will say it is low drainage density. The next question it can be that why is it that why is the area identified above having that kind of drainage density? That means if you have identified it as a high drainage density, then you have to give reasons for why is it having a high drainage density. So these are some of the factors that you are going to apply. And that one will be maybe 2 times 2 or 2 marks for that particular area. Now you also look at this one, which is talking about the low drainage density, meaning that if a low drainage density means fewer streams. And in most cases, if the streams are few, it is because there is limited rainfall. The streams are going to be few because the soils are softer or the soils are porous, so that there is more infiltration than surface runoff. Then the slope might be gentle. If the slope is gentle, meaning that less surface runoff, more infiltration, lots of vegetation. Like I told you that lots of vegetation, it acts as the binding factor of the soil, more infiltration, and less surface runoff. So those are kind of the aspects that are going to be applicable under that line. So meaning that MAP work can also be applied on drainage density. Okay, hope it is clear, learners. We continue and look at another area. Okay, another area that I want us to look at is basically what we call Another area that I want us to look at is now what we call stream ordering. Stream ordering. Stream order meaning that we're looking at how the tributaries are existing in the drainage basin. And now we have, in this case, I think if you remember very well in your classes, or you must have looked at what we call the first stream order, which we call the independent stream, the second stream order, when 1 and 2 have joined. Like for example, 1 and 1, here we have 1, 1, it forms the first stream order. 1 plus 1, it forms the second stream order. 2 plus 2, it forms the third stream order. 3 plus 1 still 3, 3 plus 2 still 3, but 3 plus 3 still, that forms 4. Let us look at this. This is a river that is flowing from this other area, okay, because this is where we have the independent streams, to this other area. In other words, this is going to be the source up here or the confluence. The source or the catchment area. Okay. Now, when you look at this, here we have, actually, let me choose a different color here. When you look at this, this is 1 and 1. Yeah? This is 1 and 1. So independent stream with independent stream, what does it form? 2. Okay. But because this one is 1, this one remains 2. And because this one is 1, this one comes. So 1 plus 1 is what? Is 2. So this and this 1 and 1, it forms what? 2. Meaning that 2, if this is 2, okay, and this is 2. So 2 and 2, it forms what? 3. Can you see that, learners? So this is 1. So this one remains 3. This is 1. This one remains 3. But we come here. So there is this and this. So 1, okay, 1 and 1. Okay, hold on. Sorry for that. 1. So 1 and 1, it forms 2. This is still 1. This is still 1. So 1 plus 1, it also forms 2. This is 1. This is 1. It forms 2. So 2 and 2, it forms what? 3. So this is 1. It remains 1. Meaning that 3 and 3, it forms what? It forms 4. That's why you see here is 4. So this is stream ordering. In other words, you can be given a block or you can be given a section on a map, and there is those kind of streams, and they want you to determine the stream order. Let me say determine the stream order of this section here only. This one here, this river here. Determine the stream order of this river here. What do? You go and start looking for which ones are independent. So if this joins with this one, it is 1 and 1, that means it is 2. Then you check the nearby one. You check the nearby one. So this and this one, they are joining and they are independent, so they form 2. So 2 and 2, they form 3. You look at all the corners. You look at all the corners and determine which stream ordering is it. Okay. So please, learners, I don't want you to mix the mathematical concept with the geographical concept. I know some of you, when it comes to mathematics, 2 and 2, it can't form 3. Okay. So 1 and 3, it can't form 3. But in this case of stream ordering, that is how it is supposed to be looked at. Okay. So please don't get confused. All right. So that is the way it is supposed to be. So for now, because of road shading that I'm anticipating in the next 4 minutes, what I'm going to do, I'm going to first of all end here for now. Then I'll start from there next time. Okay. See you. Bye.